Hey everyone, welcome back to the deep dive. You know you're here because you like to stay ahead of the curve.
That's right. We cut through the noise and bring you the insights that matter. And today, well, we're diving into some pretty exciting stuff from OpenAI, specifically their latest advancements in AI audio models.
Yeah, they just dropped a whole bunch of updates and it seems like everyone's talking about it, so we figured it was time for a deep dive.
Absolutely. And we've got a great source to guide us, Matthew Berman's in-depth breakdown of these announcements. And what we really want to explore is what these audio updates, what they mean for the future of how we interact with technology using our voices.
Right, because it's one thing to have, slightly better speech-to-text or, a new text-to-speech voice, but Berman seems to be hinting at something much bigger.
Exactly. He's really enthusiastic about this idea of moving beyond just text-based AI to a future where we're interacting with much more sophisticated AI systems using voice.
And he kept using this term voice agent. So let's start there. What exactly is a voice agent and why is Berman so excited about them?
Well, he describes voice as this, incredibly natural human interface.
Right.
Which I think we can all relate to. I mean, we've been using our voices to communicate since, the dawn of humanity.
Yeah.
But his point is that we're really only scratching the surface of how we could leverage voice to interact with technology.
Okay, so he sees voice as this kind of untapped potential just waiting to be unlocked.
Exactly. And that's where voice agents come in. He sees them as these AI systems that can essentially act independently using voice as their primary interface.
So give me some concrete examples. What would a voice agent actually look like in the real world?
Well, think about like the text-based chatbots we've all encountered online, for customer service or technical support. A voice agent would be the same concept. But instead of typing, you're actually having a spoken conversation with the AI.
Okay, that makes sense.
He also gave some other really compelling use cases, like imagine AI-powered language learning coaches. You could practice your pronunciation with it, have it generate personalized lesson plans, maybe even have full-on mock conversations to improve your fluency.
Oh, wow. That's interesting.
Yeah, it really opens up a lot of possibilities for much more interactive and engaging learning experiences.
And it sounds like Berman's not just theorizing about this. He actually shared a personal example of how he's already using voice in a really advanced way.
Yeah, he talked about how he uses the advanced voice mode on his iPhone to get information quickly when he can't look at the screen, like when he's driving.
Right. Makes sense.
But he did mention wishing for faster response times, which kind of highlights a key challenge in this whole voice interaction space, latency. The delay between you speaking and the AI responding.
Yeah, that makes sense. If it's going to be a truly natural interaction, it needs to be pretty much instantaneous.
Exactly. So that's definitely an area where there's still room for improvement. But the fact that he's already integrating voice so seamlessly into his life, shows that the demand for this kind of interaction is already very real.
So now let's get into how these voice models actually work, because Berman walked through two main approaches. And the first one he calls the more sophisticated approach, which is speech-to-speech. So walk me through that. What does that mean?
So in a speech-to-speech model, the audio input that the AI receives goes directly to audio output without ever being transcribed into text.
Oh, interesting. So it's bypassing that whole text conversion step.
Exactly. And he uses ChatGPT's advanced voice mode as an example of this direct audio-to-audio approach.
And what's the advantage of doing it that way?
Well, the key benefit is that it allows the AI to better understand and retain the nuances of human speech. Things like intonation, the speaker's mood, where they place emphasis in a sentence.
Okay. I can see how that would be important.
Because you're not converting the audio to text and then back to speech, those subtle cues don't get lost in translation, so to speak.
Right. It's like preserving the richness of the original spoken message.
Exactly. And not only can the AI understand those nuances better, it can also reflect some of them back in its own spoken responses, which leads to a much more natural and expressive interaction.
Okay, I'm starting to see the appeal of this speech-to-speech approach. It's all about preserving that human element in the conversation.
Exactly. It's about going beyond just the literal words being said and capturing that deeper level of communication that we humans do so naturally with our voices.
So that's the speech-to-speech approach. Now, what about the other one, the one he calls the more traditional approach?
Yeah, so the more traditional approach, which is still widely used, involves multiple steps. It starts with converting the speech to text. Then that text gets processed by a language model to understand the meaning, and then finally it's converted back into speech using a text-to-speech engine.
Okay, so it's a multi-step process as opposed to that direct audio-to-audio approach.
Right, and it definitely has its advantages.
Yeah.
Berman pointed out that this traditional method offers a lot of modularity, meaning developers can choose what they consider to be the best performing models for each specific step.
Okay, so they can pick and choose the best speech-to-text engine, the best language model, and the best text-to-speech system.
Exactly. And that can lead to high reliability, especially because text-based AI models have been around longer and tend to be very robust.
Right, they've had more time to mature and be refined.
Plus, it's often easier to integrate this approach with existing text-based AI systems and workflows because so much of the AI world is already built around text.
Okay, that makes sense. So there are definitely some good reasons why this traditional approach is still widely used, but I'm guessing there are also some downsides.
Yeah, absolutely. The main drawbacks are the potential for increased latency and the potential loss of emotional information.
Okay, let's unpack that, starting with latency. What's the issue there?
Well, because you're doing all these conversions between speech and text, it just takes more processing time, which can result in a less fluid and responsive user experience.
Right, it's like having a conversation with someone who takes a long time to process what you're saying and then takes even longer to formulate a response. Yeah.
Exactly. It can really disrupt the flow and make it feel less natural.
And then what about the loss of emotional information you mentioned?
Well, when you convert speech to text, you inevitably lose some of the richness of the original spoken message. Things like the tone, the emphasis, the speaker's underlying emotion.
Right, it's like trying to convey sarcasm or excitement through a plain text message. It just doesn't always translate effectively.
Exactly. And Berman even brought up how in the world of text, we've developed all these ways to add layers of meaning beyond just the words themselves, like italics, bolding emojis.
Right.
But we don't really have those same widely adopted conventions for capturing those nuances in speech to text.
Yeah, that's a really good point. It's like we're still figuring out how to encode and decode the emotional language of speech in a way that AI can truly understand and then reproduce.
Exactly. And that's a really fundamental challenge that researchers are still working on.
Okay, so that gives us a good overview of the two main approaches. Now let's get into the specifics of what OpenAI just announced, starting with the speech-to-text models GPT-4 Transcribe and GPT-4 Mini Transcribe. What's the big news here?
Well, the headline is that these new models significantly outperform OpenAI's previous Whisper models on a wide range of languages.
Oh, wow. So it's a pretty big step forward in terms of accuracy.
Yeah, and Berman quoted the announcement, which claimed that they saw improvements on literally every language they tested. So that suggests a pretty substantial gain in both accuracy and reliability for speech recognition.
And what's driving these improvements?
Well, they've built these models on top of OpenAI's large speech model, which has been trained on a massive data set of trillions of audio tokens.
Audio tokens.
Yeah, think of them as like the building blocks of sound. The more the model hears, the better it gets at recognizing and producing all sorts of different speech patterns and nuances.
Okay, so it's all about the data. The more data, the better the performance.
Exactly. And they've also incorporated their latest AI technology and architecture into these new models.
So it's a combination of a larger data set and more advanced AI technology.
Right. And then there's the mini version of GPT-4 Transcribe.
Right, GPT-4 Mini Transcribe. So what's the difference there?
Well, as the name suggests, it's a smaller model, which means it's faster and more efficient in terms of the computing power it needs.
Well, it's kind of like a lighter weight option.
Exactly. And the goal was to retain a very high level of accuracy while offering those benefits of speed and efficiency.
So it's a trade-off, a little bit less accuracy for faster performance and lower resource requirements.
Well, they claim that it still maintains a high level of accuracy. It's just optimized for those use cases where speed and efficiency are more critical.
Okay, that makes sense. And how do they measure accuracy when it comes to speech to text?
The standard metric is word error rate, which is essentially the percentage of words that the model misinterprets.
So a lower word error rate means higher accuracy.
Exactly. And OpenAI highlighted massive improvements in these error rates compared to their previous models.
But they didn't give any specific numbers.
No, Berman didn't provide specific figures in the material we have, but the emphasis on massive improvements certainly suggests a significant jump in transcription quality.
Okay, fair enough. Now let's talk about the cost, because these advanced AI models don't come cheap. What's the pricing structure for these new speech-to-text models?
So GPT-4 Transcribe is priced at 0.06 cents per minute of audio, and GPT-4 Mini Transcribe is offered at 0.03 cents per minute.
Okay, and how does that compare to their previous pricing?
Well, interestingly, Berman pointed out that the price for the standard GPT-4 Transcribe is actually the same as their previous Whisper model, so they're offering increased performance at the same cost.
That's good.
And then the mini version provides a more affordable option for those who need it.
Right. And Berman brought up an interesting point about the cost comparison with open source models because those are effectively free.
Right. But he also acknowledged that you need the infrastructure to run them effectively.
Right. So there's a trade-off there. You might save money on the model itself, but you have to invest in the infrastructure to support it.
Exactly. And his point was that for certain use cases where maybe a small difference in accuracy isn't critical, the cost savings of using an open source model could be significant.
Yeah, that makes sense. It all depends on your specific needs and priorities.
Right. And he also pointed out that many open source options can be run locally, which might be preferable for reasons of data privacy or to minimize latency.
Okay, so there are definitely some factors to consider when deciding whether to go with a commercial model like OpenAI's or an open source alternative.
Exactly. It's not a one-size-fits-all situation.
Now, beyond just the core transcription capabilities, it sounds like OpenAI is also making some notable improvements to their speech-to-text API itself.
Yeah, there are several key enhancements. One is continuous audio streaming to continuous text output.
Okay, and what does that mean in practical terms?
So it means that the model doesn't have to wait for the entire audio input to finish before it starts providing a transcription. It's constantly processing and outputting text as the audio is coming in.
Oh, I see. So that makes it much more responsive in real time.
Exactly. It creates a much more fluid and natural user experience.
Okay, and what other enhancements are there?
Well, they've also added noise cancellation to improve accuracy in environments with background noise, which is super important for real-world applications.
Right, because it's not always going to be a perfectly quiet studio environment.
Exactly. And then there's this really interesting feature called a semantic voice activity detector.
Semantic voice activity detector? What is that?
So it basically uses AI to figure out when the user has finished speaking based on the natural pauses and flow of the conversation.
Oh, wow. That's pretty clever.
Yeah, it's really smart. And it means developers don't have to implement their own complex logic for segmenting the audio.
Right, so it makes it much easier to build those natural feeling voice interactions.
Exactly.
It's all about removing those technical barriers so developers can focus on creating great user experiences.
Okay, now let's switch gears to the other side of the audio coin, text-to-speech. OpenAI announced GPT-4 Omni TTS, and the big news here seems to be the ability for developers to control not just what the model says, but also how it says it.
Yeah, that's really the game changer here. They've introduced this instructions field where developers can specify the desired tone and delivery style for the synthesized speech.
So instead of just getting the same robotic voice every time, you can actually inject some personality and emotion.
Exactly. And Berman highlighted a really striking example. They created a mad scientist voice and had it read some lines.
And it was pretty convincing.
Oh, yeah, it was amazing. The line was, "Stars tremble before my genius. The rift is open, the energy surging unstable. Perhaps dangerous, most certainly Captain Ryland."
Wow. And it sounded like it was straight out of a sci-fi movie.
It really did. And then they had the same voice read something completely mundane like, "This live stream is going really well. You're doing great."
And it sounded totally normal. Yeah, it was incredible. The contrast really showcased the level of control they've achieved.
But Berman also made a really interesting point. He said that while this level of control over tone and emotion in text-to-speech is a huge step forward, the real challenge is still on the other side of the equation.
Right, being able to accurately capture those same nuances when going from speech to text.
Because that's where we lose so much of the richness of human communication.
Exactly. We can synthesize pretty convincing emotions in text-to-speech.
Yeah.
But being able to actually understand and interpret those emotions when someone is speaking, that's the real frontier.
It's like teaching AI to not just speak, but to truly listen and understand.
Exactly, and that's a much more complex problem.
So it sounds like there's still a lot of work to be done in that area.
Oh, absolutely. But it's an incredibly exciting area of research with huge potential.
Now, for those who want to actually build applications leveraging these new voice capabilities, OpenAI also updated their Agents SDK. So what's new there?
Well, the main focus of this update was to make it easier to turn existing text-based AI agents into voice-enabled agents.
Oh, so it's all about simplifying that integration process.
Exactly. And Berman showed a demo where a voice agent responded to a query like, "Hey, what was my last order?"
Okay, and what happened?
Well, the agent was able to access the user's order history and provide specific details about the product and the order number, all through voice interaction.
So it was like having a personal shopping assistant, but with your voice.
Yeah, exactly. And it really highlighted how seamlessly they've integrated voice into these AI workflows.
Okay, now last but not least, let's talk about debugging, because that's a critical part of any software development process. And it sounds like OpenAI has made some improvements in that area too.
They've significantly updated their tracing UI to now include support for audio.
Oh, that's interesting. So what does that mean for developers?
It means they can now visually trace the flow of voice conversations. They can actually listen to the audio at different stages, examine the associated metadata, and see a detailed timeline of events.
So they have much greater visibility into what's happening under the hood.
Exactly, which is incredibly valuable for identifying and fixing any issues and making sure the voice agent is behaving as intended.
Right, because when you're dealing with something as complex as voice interaction, you need all the debugging help you can get.
Absolutely. And these new tools should make it a lot easier for developers to build robust and reliable voice applications.
So to recap, it seems like OpenAI has made some pretty impressive strides in the world of AI audio. What would you say are the key takeaways from our deep dive into Berman's analysis?
I think the big highlights are definitely the improved accuracy and efficiency of speech-to-text with those new GPT-4 models.
Right.
And the fact that they're now offering that kind of performance across a wider range of languages is huge.
Yeah, that's going to open up a lot of doors for developers around the world.
Exactly. And then the granular level of control they've achieved with text-to-speech voices using GPT-4 Omni-TTS is really exciting.
Yeah, being able to create those really expressive and nuanced voices is going to transform how we interact with AI.
Absolutely. And then on the development side, the updated Agents SDK and those enhanced debugging tools are going to make it much easier for developers to build and refine these sophisticated voice-integrated applications.
So it feels like we're getting closer to that future Berman envisioned, where we're interacting with AI in a really natural and intuitive way through voice.
Yeah, he's definitely bullish on the future of voice as an interface for AI, but he also acknowledged that text-based interfaces aren't going away anytime soon.
Right. It's not a matter of one replacing the other. It's more about expanding the range of options.
Exactly. And as voice technology continues to improve, it's going to become a more and more integral part of how we interact with the world around us.
So it's definitely something to keep a close eye on.
Absolutely. And I think it's also worth reflecting on the bigger picture, as these models get more sophisticated. And if technology can truly learn to accurately capture and interpret the subtle emotions in our voices through speech to text,
Yeah.
what entirely new forms of communication and understanding might emerge?
That's a really interesting thought.
Yeah, think about the potential impact on things like therapy, customer service, even artistic expression.
Yes, a whole new world of possibilities.
Exactly, and it's a future that's unfolding right before our eyes.
Well, this has been a fascinating deep dive into the world of AI audio. Thanks for joining us.
It's been a pleasure.
And for all of you listening, thanks for diving deep with us.
We'll see you next time.
Until then, keep exploring, keep learning, and keep asking those big questions.
And remember, the future is listening.
So make sure your voice is heard.
We'll catch you in the next deep dive.